So what is the microspace philosophy? I shamelessly stole this slide from Rob Z at UTIAS, so I have to give him full credit for this. But I really like this diagram that he put together that really graphically illustrates what we mean when we're talking about shrinking down, well, not only just the physical size, but the cost of space as well. So you have something like the Hubble, which is about 11 tons and cost about $1.2 billion, and each of the subsequent space shuttle servicing missions was on the order of $400 to $500 million or something. And what the hell is that? Don't say. Yeah. So we're going back to something like the MOST satellite, the Hubble Space Telescope, the stellar photometry experiment that UTIAS did, on the order of 55 kilograms. Basically, things that are 100 kilograms or less are classified as a microsatellite class, and things that are, say, 15 kilograms or less are in the class of nanosatellites. So there's an example there to scale. And the costs, again, and the ability to rapidly develop and launch these things in a timely and cost-effective manner is really what makes the microspace approach very, very attractive. So our first satellite, the first project of the Mission Development Group was NTS, Nanosatellite Tracking of Ships. It was based on the UTIAS GNB, the Generic Nanosatellite Bus. So this is a 20 by 20 by 20 centimeter cube. If you ever have the privilege of actually coming to ComDev, and I hope you will at some point, in our lobby we have a full-scale model of the spacecraft, and people are pretty amazed that something this small is actually a fully functional satellite, but it is. It was launched in April of 2008. I talked earlier about our collaborations with ISRO, the Indian Space Research Organization. They have a launch vehicle, the PSLV, the Polar Satellite Launch Vehicle. And on this particular mission in April 2008, this was the one that deployed NTS as a secondary payload. So again, in the spirit of sort of reducing cost, because these are small enough satellites, you can launch them as piggybacks or secondary payloads on somebody else's rocket. NTS weighs 6.5 kilograms only. So literally, this was the upper stage of the launch vehicle. This is the interface with the second stage of the launch vehicle. And you can see various deployment mechanisms here for other secondary payloads. This was the main satellite, and that's us right there. The Indians were really, really very remarkable. There's a criticism, and I think it's a justified one, that space is often very bureaucratic and there's like tons of paperwork to fill out to get any little thing done. So my understanding of the story is they literally said, well, can't we just stick our satellite on the side of the upper stage? And then they kind of said, oh yeah, sure, why not? And that's exactly what they just kind of stuck it on the side, and then when they got up there, they chucked it overboard. And it's been working great. So the mission of NTS, as the name implies, is to demonstrate ComDev's technology for detecting AIS signals from space. AIS is Automatic Identification System. This is a transponder that is mandated by the International Maritime Organization that any ship over 30 metric tons has to carry one of these transponders. And it basically blurts out the ship identification, its destination, its current speed and heading. And it's a safety type thing, so other ships will be able to know what other vessels are in their proximity and take corrective action as necessary. Now, traditionally, with terrestrial-based receivers on the coast, you can only look about 50 nautical miles up. Thanks to our receiver technology, we can now place these on satellites and have a truly global view for the first time of ships and maritime traffic from orbit. This is I'll show you a bigger picture later, but that's a collection of NTS data over the course of a year. And I thought it was just really cool to see things like the shipping lanes across the Indian Ocean and so forth. A lot of implications here for security, for environmental protection, and for commerce as well. Our next mission is called M3MSAT, and I think it's called M3MSAT because the actual name is really long and I always forget it. It's Maritime Monitoring and Messaging Microsatellite, and it's co-funded by Defence Research Canada and the Canadian Space Agency. It has 2 payloads. The primary payload is another one of these AIS receivers, and the second payload is a comms demonstration for DRDC. So we just passed critical design review on M3MSAT, and it's scheduled for launch next year. The M3MSAT spacecraft itself, I mentioned that NTS was based on the UTIUS generic nanosatellite bus. The bus platform for M3MSAT is purely a ComDev development. So a couple of years ago, the Canadian Space Agency put out a spec called the Multi-Mission Microsatellite Bus. Their idea was that they would try to develop one generic platform for Canadian applications that you can kind of plug and play different payloads in, and otherwise mass produce these little satellites and then shoot them up, say every year for a very responsive and comprehensive access for Canadians to space. Well, we took that spec, we improved on it, we improved the power available to payload and so forth. So we're calling it now the AIM class bus. It's the ComDev Advanced Integrated Microsatellite Bus. And this is going to be one of our host platforms going forward for other missions that we're considering. So I talked about the AIM class bus, and we've used the generic nanosatellite bus for NTS. In collaboration with UTIUS, again, we're also working with them on what's called the NEMO class bus. This is basically 2 of these generic nanosatellites put together for double the capacity. So that's about 30-ish kilograms, of which about 17 is dedicated to payloads. One of the things we've also done is what are called hosted payloads. So if we have an instrument that can fly on another platform that's not necessarily our own spacecraft, this particular case is actually an upper stage of an Indian rocket. And we were testing radiation susceptibility and the survivability of our receiver technology. So just some breadboard and engineered model type hardware launched up there on a very rapid schedule. I forgot to mention that the NTS satellite, from start to finish, so from a blank screen, a blank piece of paper to the launch in April 2009 took 9 months, which we believe to be, if not a record, then something that's really a trendsetter in the space industry. We also have a hosted payload going up, another AIS receiver on the Indian RADARSAT-2 satellite that's going up in the fall. So India has really a very impressive emerging space power, and it just makes a lot of sense for Canadian companies and for Canada to diversify and find partners, in Japan, in the United States, in Europe, and now in India. It's really a positive development to have truly a global space effort. So I mentioned NTS